Now let's consider this situation, and in this situation we are having a material, and that material here is air, and let's say here is water or glass or any other material. So the refractive index of this means which is the air, and the refractive index of water, we know that the refractive index of water is greater than the refractive index of air. So we are having this situation that the light, now we will consider that the light is actually produced inside water and it is going in air. So for this one, let me say that when light will go exactly in a straight line from the source here, then it will not bend but it will go along the perpendicular line and it will be like this one. So we are having no deflection or refraction of this light and it will go perfectly there. Now when we will have, now this will be the incident angle and this will be the reflected angle. Let's say we are having now the light in this direction. So now it is in oblique incidence. So principally this light is supposed to go this way, means exactly in this direction, but is the refractive index of light, we see that is the refractive index here is more and here is less. So what will happen, that this will deviate now more from here, from this line, means earlier it was going towards the perpendicular and now it will go away from the perpendicular. It will be this situation, like the light now goes from here. So this was the line which was the actual direction of it, and now it will go away even from that line. So the light will actually go now this way. So this will be the angle of incidence theta I, and this will be the angle of transmission. And now when we will consider that what will be that angle, for which the incident, means what will be that incident angle for which this transmission angle will become exactly equal to 190 here. So what will be that angle? So I will come back to this equation, and this I will say that the sine theta I is equal to nt over ni and sine theta t. Now here I will say that what will be that angle? I will define the angle that when theta I is equal, is defined as the critical angle. When theta I is equal to the critical angle, then theta t is equal to 90 degree exactly, or I say pi by 2 radians. So what will be that critical angle that will give this thing? So putting the values here, and I will get that for this sine of theta critical will be nt. Nt is this one, air, and for which I can approximate the refractive index is 1, and this is nt divided by ni, and this is 1.33, and here the angle sine theta 90, so this is equal to 1. So 1.33, and from here I can calculate that theta t will be the sine inverse of 1 over 3t. So I will write this is critical. So the critical angle will be equal to 1.33 and this will be 48.75 degrees. Similarly, if this medium is not water but this is glass, then the critical angle, the theta critical, will be 1 over 1.52 into 1 and this will be equal to 41.1 degree. So it means that more the refractive index of a material and from which the light is going out to the less refractive index, its critical angle will be smaller. So I say that if I will keep an angle of 50 approximately here, so this is for example 45 line. So if I make an angle of, let's say here, and this angle is, let's say 48, then the reflected light on the transmitted light will be in this direction. So this angle is approximately 48 degree or 48.75. So I say this is approximately 49 degree. So I will have this transmission. The transmission will just go along the boundary and will not go to another medium. Similarly, if the angle for any incident angle which will be greater than the critical angle, then what I will see that for any other angle greater than that one, the light will actually come back to the original material, from the material from which it has gone into. And for this we will say that the light has totally reflected internally, means no light has gone to another medium but it has totally internally reflected, and this phenomenon we name is total internal reflection. This phenomenon is called the total internal reflection, which we shortcut write is TIR. And this is the total internal reflection. Now similarly, if we are having a material here and this light is coming in from that material and this refractive index is more than this refractive index, and we will have the same phenomenon as we did from here to there. So this will give rise to total internal reflection, and one of the best example of the total internal reflection is the mirage phenomenon, which we observe, or we see that when in a hot weather we go on a road, then we see that some water is there. In reality it is not water, but it seems like water. So that is the appearance of the total internal reflection, means the total light reflects in the same medium.